For many days, a man in Austria sat watching trains go by, He was curious to know why the pitch of the whistle changed, and he gave us his Doppler concept in 1842. In 1842. What then is this Doppler concept? Let us restrict our attention to sound waves in air. Sound waves in air are longitudinal. It means that when a source vibrates with a frequency of say 50 Hertz, we understand that the vibrating source injects 50 compressions per second into the medium, and these compressions get pushed forward with a velocity given by v is equal to n lambda, where lambda is the wavelength and n is the frequency of the source. When the source and the observers Ram and Tom are all stationary, the distances are fixed. Now, both Ram and Tom receive 50 compressions per second in their respective eardrums. So, they both hear the same frequency, that is the same pitch. Suppose now the source moves towards Ram. See now here how Ram receives more than 50 compressions per second. So, Ram hears a higher pitch, even though the pitch of the source is the same. This is the key point of Doppler effect. At the same time, Tom hears a lower pitch because the compressions have to travel a longer distance at the same velocity. The source is moving away from Tom. If the source were to move towards a stationary observer, there is an apparent increase in the observed frequency, but if it moves away from a stationary observer, there is an apparent decrease in the observed frequency. So, Doppler effect can be described as the apparent shift in the observed frequency when the relative distance between the source and the observer is changing. Doppler effect is applicable to any type of waves. In fact, from the change in frequencies of the rays received from the eastern and western edges of the sun's disk, it has been proved that it is rotating about its north-south axis. Doppler effect is extensively used in medical diagnosis. For example, parents explode with joy when they can see and hear the heartbeats of a 20-day-old fetus in the womb. In sports, the speed of a moving cricket ball is measured using Doppler effect. We can go on with the list. So, when you are captured by a moving object, think of Doppler.